Yes, and welcome to our Objective 1.6 sample problems. Objective 1.6 says I can use function notation to identify the output of a function for a given input. So let's get started. Let's look at letter A here. G of n equals the negative absolute value of n minus 3 plus 2. Find g of 5. So remember, this input, 5, is going to replace anywhere there is n. So we'll say g of 5 equals the negative absolute value of 5 minus 3 plus 2. So the negative absolute value of 5 minus 3, so that would give me 2 plus 2. The absolute value of 2 is just 2, since 2 is 2 units away from 0. And then we have negative 2 plus 2. So g of 5 will equal negative 2 plus 2 is 0. And there we go. Let's look at letter B. H of k equals the square root of k plus 21 minus 3, find h of 4. So I will say that h of 4 equals the square root of 4 plus 21, and then we'll subtract 3 from that. Square root of 4 plus 21, 4 plus 21 is 25 minus 3. The square root of 25 is 5 minus 3. Now some might say, isn't it plus or minus? If we are assuming that there's no plus or minus written, we'll just assume the positive here. So 5 minus 3 is 2, which tells me that h of 4 will equal 2. And there we go. Very nice. Let's look at letter C here. K of t equals negative 2t squared minus 5. Find k of 3. So I'll say k of 3 equals negative 2 times 3 squared, and then we'll subtract 5 from that. All right, so order of operation tells me I need to do this exponent first. So negative 3 squared is 9 minus 5. Negative 2 times 9 is negative 18 minus 5, and negative 18 minus 5 is negative 23. So that is what k of 3 equals, negative 23. There we go. And let's try letter D here. Oh, cool. Notice we have multiple x's in here, so 9 will replace both of those. So we'll say n of 9 equals 3 times 9 minus 4 over 6 times 9 plus 1. All right, 3 times 9 is 27 minus 4. 6 times 9 is 54 plus 1. 27 minus 4 is 23. 54 plus 1 is 55. And I don't think we can simplify that anymore since 23 is a prime number. So we'll say that n of 9 equals 23 over 55. There we go. Awesome. Let's look at letter E here. Okay, so notice now we're going to be plugging in an expression. So for all of A, B, C, and D, we were plugging in numbers, so our outputs were numbers. This time, plugging in an expression, so our output will be an expression. So we'll say f of negative 3t equals the absolute value of negative 2 times negative 3t, and then minus 2. So negative 2 times negative 3t would become the absolute value of 6t minus 2. And that is actually all I can do, isn't it? So f of negative 3t equals the absolute value of 6t and then minus 2. Awesome. Let's look at letter G here. G of a equals negative 5 plus 2a. Find g of 1 plus a. So g of 1 plus a will equal negative 5 plus 2 times 1 plus a. So that'll be negative 5 plus 2 plus 2a. Negative 5 plus 2 becomes negative 3 plus 2a. So we can say that g of 1 plus a equals 2a minus 3. Awesome. Couple left. Let's try letter G here. H of x equals negative 3x squared plus 4x. Find h of x minus 2. So we'll say h of x minus 2 equals negative 3 times x minus 2 squared plus 4 times x minus 2. Okay, so let's write this out. Let's expand this multiplication. Remember that this is x minus 2 squared, so it's x minus 2 times itself. Plus, and we can go ahead and do some distributing here. 4x minus 2 becomes 4x minus 8. So now we'll have negative 3 times x minus 2 times x minus 2 leaves us with x squared minus 4x plus 4 plus 4x minus 8. And now we need to distribute that negative 3 into everything. So we will have negative 3x squared plus 12x minus 12 plus 4x minus 8. We can combine some like terms here, and we'll find that h of x minus 2 equals negative 3x squared. 12x plus 4x gives me plus 16x. Negative 12 minus 8 gives me negative 20. And that's all I need to do. I don't need to try to solve this or factor it or anything like that. Remember, we're just simplifying. So negative 3x squared plus 16x minus 20 is our final answer for h of x minus 2. Last one here. F of x equals 2x times the quantity x minus 3. Find f of x plus 1. Cool. This is a good one. So f of x plus 1 equals 2 times the quantity x plus 1. And that'll be times the quantity x plus 1 minus 3. All right, so order of operations tells us to take care of inside those parentheses first. So we'd have 2 times x plus 1 times x plus 1 minus 3. Well, 1 minus 3 is negative 2, so this will become minus 2. Now from here, your order really doesn't matter how you're going to multiply. I'm going to do this first one first. So I will say 2x plus 2, and then all of that is going to be multiplied by x minus 2. When I do that, I'll get 2x times x is 2x squared. 2x times negative 2 is negative 4x. 2 times x is positive 2x, and 2 times negative 2 is negative 4. Combine our like terms, and we'll find that f of x plus 1 equals 2x squared minus 2x minus 4. Now you might be thinking, Mr. Carter, should we factor out the 2? Do we need to do that? No. Don't need to do any of that. We have fully simplified. They're not asking us to factor or anything like that. We're good. So we can call this good for letter H. And we can call that good for our objective 1.6 sample problems. Hopefully you're feeling a little better about these. Let me know if you have any questions. Otherwise, go ahead and get started on those practice problems for 1.6. This is Mr. Carter signing off. I'll see you next time.